Hey guys, this is Jim. Welcome to my YouTube channel. In this video, I discuss some important properties of parallel lines. I also presented some examples for you to understand better parallel lines. Parallel lines. Two lines are said to be parallel when they are equidistant and will never intersect. Being equidistant means that the distance of any point on one line from the nearest point on the other line is the same for all points. Meaning to say, this from this point on this line to this nearest point on the other line, well, suppose the distance is d1, then we'll have another point here and measure the distance of this point on this line from the nearest point on the other line. Okay, say this point here, we'll name it as d2, etc. and etc. Okay, d3 for that distance, then d4 for that distance. That means to say that all these distances, d1, d2, d3, d4, etc. and etc. are the same. If we denote this line, the first one by L1 and the second one by L2, then a mathematical statement can be said L1 is parallel to line L2. This is an accepted notation to denote that these two lines are parallel lines. Now, we'll examine some useful properties of parallel lines. One useful property of parallel lines is that they have the same slope. Meaning, if we denote by M1 the slope of line L1 and M2 the slope of line L2, then we would say that M1 is equal to M2, right? Another property is that two lines are parallel when the coefficients of x are the same in the given two equations and the coefficients of y are also equal. That is, the two equations only differ in the constant terms. Suppose we have this pair of equations. First, 3x minus 8y equals 4 and 3x minus 8y equals 7. We can observe here that the coefficients of x are equal and that of y are the same. So we then conclude that these two lines represented by these two equations are indeed parallel. Let's have another set of equations. Suppose we have negative 2x plus 3y equals 1 and negative 6x plus 9y equals 5. The question is, are these two lines represented by these two equations parallel? Okay, so to see this, since originally looking at the coefficients, they are of course not equal. However, if we simplify the equations, well, equation 1 is already in simplest form. If we divide equation 2 by the common factor of the coefficients of x and y, that is, if we divide this whole equation by 3 or multiply by 1/3, then we'll arrive at an equivalent form of the equation which is negative 2x plus 3y equals 5/3. And this leads us to the same coefficients for x and equal coefficients for y. Meaning to say, this tells us that these two given original equations are equations of parallel lines. So meaning to say, if we are given two equations and originally we are seeing that the coefficients of the x and y variables in the two equations are somewhat different, try to simplify the equations. Then if in their simplest forms, the coefficients of x are equal and the coefficients of y are the same, then we can conclude that the two lines are indeed parallel. Another important principle that we need to know about parallel lines are the corresponding angles. Suppose we have these two parallel lines. We have this L1 and line L2, right? And we'll have this traversal line P, or sometimes referred to as the traversal line. By the way, traversal line, or simply traversal, is a line that intersects two or more other lines. A traversal intersects two lines on two distinct points. The concept of traversal lines is very useful, especially when we are dealing with parallel lines. Given this traversal line T, we form what we call corresponding angles. The corresponding angles here are this angle theta 1 and angle theta 2, right? Here, angles theta 1 and theta 2 are corresponding angles. Corresponding angles are angles that are in the same location or in position relative to lines intersected by the traversal line. Now, when a traversal intersects two lines, the two lines are parallel if and only if the corresponding angles are congruent. Meaning to say, if and only if theta 1 is equal to theta 2. Meaning, if these corresponding angles here are equal in measure, then these two lines, L1 and L2, must be parallel lines. Alright, we'll have some examples. First, we'll find the equation of the line that is parallel to this line. Given this equation, y is equal to 3x plus 2 and passes through the point 1, 2. Meaning to say, we'll find the equation of a line passing through this point 1, 2, which is parallel to this line having this equation, y is equal to 3x plus 2. Okay? Okay, so we can see here the illustration of the problem. We have here line L1 with the given equation y is equal to 3x plus 2, and we are looking for the equation of this line L2, knowing that it is parallel to line L1 and that it passes through the point 1, 2. Okay, so what shall we do here? Note that if two lines are parallel, the slopes must be the same. So we'll capitalize on the slopes of these parallel lines, especially the slope of the first equation. Meaning to say, let me solve this step by step. First, let us determine or identify the slope of line L1. And we know that the slope of line L1 is what? Okay, if you look at the given equation of line L1, this y equals 3x plus 2. It is already in the form of the slope intercept form of the line, where the slope is this coefficient of x, 3, and the intercept is that constant 2. So meaning to say, the slope of line L1 given by M1 is equal to 3. Okay, that's the first step. Now, the next step is, of course, we need to determine the slope of line L2, right? However, we know that line L1 is parallel to line L2. Of course, this would imply then that their slopes must be equal, meaning to say M1 must be equal to M2. However, in this case, 3 is the value of M1, so therefore M2 must also be equal to 3. So this is now the slope of line L2, right? Now for the third and final step, we'll now determine the equation of line L2. Okay, now capitalizing on the given, okay, we know the slope of line L2, which is equal to 3, okay, and we are also given a point on line L2 which is given by this point 1, 2. So we'll now make use of the point slope form to determine the equation of line L2. Okay, once again, the point slope form is given by this equation: y minus y1 is equal to m times x minus x1. y1 being equal to 2, that's why your y1 there, and x1 is equal to 1. Okay, so substituting these values into this equation, we'll now have y minus 2 is equal to the slope 3 times the quantity x minus x1 is equal to 1, right? Simplifying further, this will now be equal to y minus 2 is equal to 3x minus 3, right? Now we'll transform this equation to standard form by transposing this term 3x to the other side and this constant negative 2 to the other side also, to come up with negative 3x plus y is equal to negative 3 plus 2, which in turn will give us the equation of line L2, which is negative 3x plus y is equal to negative 1. Of course, we can derive an equivalent form of this equation by multiplying the entire equation by negative 1. We will have 3x minus y is equal to 1. Let's have the second example. Suppose a line passes through the points negative 1, 1 and 2, 3. Determine the equation of the line that passes through the point 1, negative 3 and is parallel to the first line. We'll be looking for the equation of that line passing through this point 1, negative 3, which is parallel to the line passing through the points negative 1, 1 and 2, 3. Okay, so these are now the lines sketched on this Cartesian plane. We have here line L1, right, passing through the points negative 1, 1 and 2, 3. And we have this line L2, okay, passing through the point 1, negative 3, okay. We are to look for the equation of this line L2. All right, so what shall we do? Okay, first, we need to look for the slope of line L1. Okay, so the slope of line L1, how do we do it? Since we are given two equations, then we can use the formula for the slope to compute for the slope m1, which is, if you can remember, the slope m1 is now given as y2 minus y1 over x2 minus x1. y2 being the y-coordinate of this second point, y1 the y-coordinate of this first point, then x2 the x-coordinate of the second point, and x1 the x-coordinate of the first point, which is now equal to, substituting these values here and this one here, will have 3 minus 1 all over 2 minus negative 1, okay, which when simplified, this is 3 minus 1 is 2, 2 minus negative 1 is 3, so the slope now is given as 2/3, right? Okay, of course the slope of line L2 will also be equal to 2/3, since we know that lines L1 and L2 are parallel lines. Okay, so we now are ready to determine the equation of line L2. Okay, how do we do it? Since we are given this point 1, -3, that point where line L2 passes through, and we are also given the slope m2, which is equal to 2/3, then we can make use of the point slope form. And the point slope form of the line is given by y minus y1 is equal to m times x minus x1. Okay, substituting the values of x1, which is equal to 1, and y1, which is equal to 3, we'll now have y minus -3 is equal to the slope being 2/3, okay, times x minus 1, right? Okay, simplifying further, we'll have y plus 3 is equal to 2/3 times x minus 1. Okay, so we'll now simplify further the equation by multiplying the entire equation by 3 to eliminate the denominator 3 there. So we'll now have 3y plus 9 is equal to 2 times x minus 1. Okay, and simplifying further, this now leads to 3y plus 9 is equal to 2x minus 2. Okay, transposing the term for x at the left side and the constant 9 to the right side, will now have the equation of line L2, which is -2x plus 3y is equal to -11. Okay, so this is now the equation of line L2. We can also derive an equivalent equation of this one by multiplying both sides of the equation by -1 to arrive at 2x minus 3y equals 11. Right, we'll have the third example. Here we need to determine whether these lines, given these equations, 2x plus 5y equals 2, and the second line, 4x plus 10y equals 4, are parallel lines, right? So here we have the equations of the two lines. We'll name them as lines L1 and L2, right? Okay, so to better analyze, it is important to simplify the given equations. Equation 1 is already in simplified form. Looking at equation 2, we have a common factor of all the terms, right? Here, the common factor is 2. To simplify, we'll multiply the whole equation by the reciprocal of the common factor 2, that is, we'll now multiply the second equation by 1/2, okay, to simplify it further. So we'll multiply this by 1/2 and we'll arrive at 4 divided by 2 is of course 2. So we'll have 2x plus 10 over 2 is 5. So 5y, which is equal to 2. Okay? We see that this is actually equation 1. Therefore, the lines are not parallel. Okay? Actually, they are coincident. By the way, coincident. So may I write here coincident? Okay? By the way, what are coincident lines? Coincident lines are lines that coincide or lie upon each other. Again, coincident lines are not considered parallel lines. I hope you learned something from this video. In my next lecture video, I'll be discussing about perpendicular lines. Don't forget to subscribe on my YouTube channel for you to receive instant notifications about newly uploaded lecture videos. Thanks for watching.